Hey guys, how's it going? This is Kyle Olson, and we've got kind of a treat today, something that I'm pretty excited about. I went to a client's home over the weekend, and I took a bunch of photos and did my investigation or whatnot, and he gave me permission to share with you guys a lot of the photos that I took. Talk to him a little bit about the channel and whatnot. The important things was that he was on a hillside, right? And it was definitely being affected by some slope creep. And I had also the pleasure of meeting with one of his relatives who was a civil engineer that was on site. So this civil and I were going back and forth and like playing with the idea of what the problems could be and the expansion soil that might have been present in the area. And we're looking around at all the different nuances that comprise this particular job site, you know. And it was it was honestly a really fun experience. The guy had a really nice family. I was on my way down to the beach, and my girlfriend happened to be with me, and she plays piano. He had a piano, so we were literally sitting there like sipping tea, being serenaded by classical piano music while discussing all of the different things that could be going on with this house. And it was a unique experience, but ultimately a lot of fun. So this is gonna be a little weird. I put the photos onto my laptop, and I'm going to try and share those with you while we go, just so we can describe stuff, right? But I'm gonna jump on into it. So remember, we've got the 1 to 3 rule. So you've got a hillside. Well, he had a hillside, bop, and his house, right, man? And you've got your 1 to 3 rule. There was a super healthy drop. Okay? I want to say it was probably at least 60 feet down to the toe of the footing. And then what does that tell us with the 60-foot drop that we assume is that slope creep, right? Is probably affecting 180 feet up. Chances are pretty high the home was in that zone, because up top we only had maybe 25 feet from the edge of the slope to the back of his house, right? So if I take my bird's eye view on top of that, you had the footprint of the home, which I'm just gonna say is this, okay? The nuances of active jobs that you're doing videos on. Anyway, so it looks like this. And in the backyard, you had your slope with a super healthy gradient. And then up front, you had the street that ran kind of like this, which also, by the way, had a slope running there. So we've got a graded lot, well, relatively flat lot actually, in a graded subdivision, sitting at the top of a hillside with 2 slopes that could be disaffecting the soil. So you already know there's going to be some things happening there, right? So the very first thing we did was look at the slope, and they had very high vegetation through and through, which was good because it helps, the root system helps tie that hillside together. No retaining wall down at the bottom, right? So it's sort of self-supported. What we also noted was they had a concrete channel, several of them actually, to carry water through and through. But we also noted that the slope was watered very heavily, okay? On top of the slope being watered very heavily and all of the other fun jazz right there, at the top they had slightly graded away from the slope. As we found out previously, that was because the water used to pond here at the top of the slope, which you guys remember with the erosion and triggering landslides and all that fun jazz, right? So with only 25 feet up top here, what appeared to be no more than maybe 30 feet away of the actual slope, and we know 180 feet is our slip, we know that this home for sure sat within the slip zone, right? So it could or could not be being affected by slope creep. Now the home had settlement issues, which is why I was there, which is why we're always called out there. But the unknowns that remain with the project, which continue to remain with the project until you do engineering, are the as-built of your footing. Maybe you've got little concrete mini piles that go down into the toe, right? That would be a huge problem for us trying to use polymer injection. That's where something more like a piering system might come into play, or maybe you need to enhance this, or a grade beam, or whatever else. So already there's ideas that are starting to form, right? But we've got a lot more investigation to do. The big question being, is there lateral movement affecting the structure, right? And how are we going to address that, and are we going to address that? So the home had settled. Let's do a different color. The home had settled in a cantilever crack, if you guys remember what that is. Cantilever crack, boom, and down, 3 inches. Oh, okay, so that means this side of the home was pretty level. This side of the home drops 3 inches, right? And at some point there was a water leak up here that affected the floorboards and the flooring, all that fun stuff. And there's a high suspicion that this water leak may have affected everything down toward the slope, right? There's also a drainage system that ran alongside the house, drainage system in the yard for the area drains, and then a planter, which will be important later. So you got kind of a lay of the land here. You got kind of what my thoughts are as far as whether or not the slope is affecting the house and what the conditions are and how we got to this spot, right? So now what I'm going to do is I'm just literally going to share with you some of the photos and the ideas that stick out to me as we go through the photos about you know, what we saw. So first things first, womp, yes, no glare. Womp. Go here, yeah, right about there. So you guys see this gap right here, right? The gap is important for 2 reasons. One, the slab is not disjointed, right? You don't have a slab here and a gap and a secondary slab, and the slab is not higher or lower than the first one, which means like pulling away, right? We call it stair-stepping away or pulling away. Stair-stepping is with regard to expansive clay soils. When the clay soil expands underneath, the joint breaks, the structure, if you assume this is the house structure, right? And this is just the slab. The slab is pushed up. It's not strong enough to pick the house up, but it's strong enough to pick up the slab. And then when the clay soil dries out, it constricts and steps a little further away, and away, and away, and away, right? That's called stair-stepping away, giving you this gap here. The other thing that could be is lateral movement. You've got slope creep running on the underside of the structure, right? It's pulling everything down and away in a slow, gentle slide. By the way, guys, this was over the course of over 15 years that we got to the situation that we're in here, okay? So it's not like all of this dropped last week. That's also a very important thing to take into consideration. But so they've got this little gap, right? And not only do you see the gap, you also see the fill here. So at some point, somebody filled this up with some sort of a caulking, and the gap has reopened. And that tells me that it's going to be a persistent, continual problem that's going to have to be addressed at some point or another, or it's something that they're going to have to expect that if you do a vertical bearing system only, the hillside movement is going to continue, and it's something that's eventually going to have to be addressed, right? So more on that later. Change. Please. Yeah. Sorry, one sec. Usually this works. Okay, well, next one. Ah! Uh-oh, I was going the wrong way. So this is a good video picture I want to show you guys. This window looks like it's been reframed. Not. So you can see bottom of the frame straight, and this window literally just bows out to the side. This gap from the bottom here leading up to the top is a huge separation, right? It's very, very important. So we know that the settlement is going that way, duh, right? So the bottom is like an anchor point. The bottom is here, and the house is tilting like so. So you can tell that the settlement heads that way in this particular picture, right? But it's a good example of how some structural elements are disaffected by differential settlement. Also important to note that when we lift, we're gonna be picking up on this side, which hopefully, as the superstructure as you pick up the footing, hopefully that tilts the superstructure back and helps to close that gap, right? But especially if it's been reframed, that's that thing where any cracks that have been filled before and closed up are gonna reopen, new cracks could appear. These could break or they could close the cracks and then reform. We just did a job in Santa Barbara for a guy. All the cracks closed up. It was like a brand new house when we were done. It was very nice. Versus something that just doesn't quite go along that way, right? We won't know until we're picking the house up. So those are risks of doing stuff like this. What? Are you gonna cooperate now? Please? Por favor? Nope. Fine. Yep. It's another one. You can see from the bottom down here. Yeah, see bottom down here, nice and snug. Top up here, nice and open. You can kind of see in the background here, the view is beautiful. And what comes with views is problems sometimes. Not a problem. Next up, another good example, up here. Once again, you can see this crack, it's stair-stepping away, right? It's been caulked before and this crack has reopened. That tells us it's a continuous, persistent problem. You can even see more of the caulking right there while you go through, boom, right? So those are all things that you're paying attention to as far as the actual house is concerned. What we're looking at here is this section of the home primarily. So right here is where we saw the caulking, those last pictures of the caulking and the separation, right? And then over here is where we saw the window. Obviously it's where the settlement was happening. So you saw the window with the gap. And right here and here was the other section where you had the caulking and the separation on the back patio, right? So we know that your slip plane all the way back here probably has movement underneath the entire thing. Yep. Another thing to note on this picture, just so you guys know what my investigation entails, you see this little mark right here, this thing right here? That's a efflorescence or a stain underneath the concrete, and usually this is indicative of water ponding, sitting for a long period. Usually there's something here. So we had a good discussion about like the water bill and the other things that you worry about when, you know, water could be present somewhere. So we know the house is being affected, and there's other things that you look for as far as hillsides and what could be causing the movement. So what we started looking at is the rest of the landscaping in the area surrounding the house. And this is really why I was excited to show you guys. You see this gap right here? That's a gap. That was like a 6-inch gap on one of the retaining walls that runs up the side of the home. That was up by this area here. So if I grab my green, this is a retaining wall that goes up, right? Like so. And that's what you're looking at right there. There. And that's what you're looking at. Right here, there's no little wall here. And there's a huge gap right there. And gaps like that, and you can see, well, you can't really see. The gaps like that tell me that there is movement or opening up, which means this wall here is going downward, right? And this area was removed here, but this area was moved here. But you can kind of see that it's disjointed a little bit and not perfectly in alignment. And either that was a really, really crappy construction job, or that's more movement right here. So everything on this side is still moving down toward the slope, right? That's a pretty clear indicator of what's going on there. You got the same gap here, where the concrete patio in front of the house here meets a planter over in this section. That's where that's at. Even the small concrete pour there has got 4-inch to 6-inch gap on this side. And this is, hey, it changed finally. So this is with, sorry. So this is with, and I lost my thought. This is with good drainage. This is with good drainage surrounding. They've already changed the grading so that the water doesn't flow to the hillside and all that fun jazz. But this tells me the hill is moving, right? This is obvious. See the settlement there? This is this section of the wall up here after the turn, right? So this is all disjointed and falling apart. And it's got the settlement, the tilt. You see the tilt, so you understand that this section here is moving down, right? This is moving down. There's separation up here that you can't really see in the photo, but this is moving down, and that tells me that this is tilting and falling off that way. That's all suggesting that all of this is moving and sliding down toward the hill. I think one more photo, you can kind of see the hill in the background there. Up here, that's the view, it's great, but you can see the settlement from here up to here is pretty severe. The drop from this brick to this brick that twisted that one, broke it off. This corner has got all kinds of loading on it that's all messed up. It's got that twist over in the corner, right? So you can see with all the photos that we had on here, there's definitely, absolutely, 100%, no doubt in my mind that there's a hillside issue that's affecting this house, right? And it's probably just gradual slope creep. This happens generally regionally, right? Which means every single house on this street is probably experiencing a lot of the same thing. So that triggers, to me, it's a good place to market as far as the foundation repair services and stabilization and all that fun jazz. Excuse me. What that also tells me is when we start addressing the actual repair, excuse me. Slip zone. So what that tells me when we start addressing the actual repair, if you do any axial, up and down, compression, down only, systems, okay, if these provide no lateral stability here, you're going to get your upward lift. You'll get your lifting with like a push piering system or it's arguable if those concrete piers will do this one, but you'll get some lift, but you're not going to get any lateral stability. So anywhere in the contract that says we don't do lateral support or blah, 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 your contract's pretty much useless, right? Next, if you do tiebacks, which provide tieback, into the slip zone, minimum 5 foot embedment into the slip zone, you can do helical piers. Those do provide some degree of lateral stability, right? So all of this continues to move here, but this here and 5 feet in should be pretty embedded to the proper torque and strength and resistance and blah, blah, blah. So this is going to be relatively stiff. That's the important thing about push piers being hollow tube, because they have no resistance, and that's why they have like bending forces and shaking and all that fun stuff. And some cities make you pour concrete down push piers after you're done to make them more rigid, right? And that does provide some lateral stability. For helical piers, this is all solid steel, right? You drive a 2-inch thick helical pier down into the ground, that's 2 inches of solid steel. So if you're anchoring the bottom here, this is going to help support, and yeah, you're still going to have the bending and the twisting forces, but the bottom is solid, and that's going to help support the house up here at the top, right? Now, if you want to address some of those lateral issues, you can do that. You can do concrete piers, you can do caissons, you can do the push pier with helical tiebacks that go into the slip plane by the same 5 feet, right? Now remember the argument that the engineers are having, that with the angled bracket that they have on the footing, there's an argument that pushing it and tying it into the slip zone will support that. And some people think that the footing will literally fall over the top of the L bracket, and it doesn't work at all. I've seen arguments on both sides. Personally, I think it provides some degree of support, absolutely, and the idea of a footing like jumping over an L bracket doesn't make sense to me. It could, but I would think more like it would collapse underneath rather than jump over. But that's just me, forces, and common sense engineering, basically. Forgive me. So you've got all this stuff. So you could address some of the lateral forces with helical tiebacks by using helical piers. You could address those forces by doing the caissons, right? Caisson embedment, blah, 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 and then put that into a grade beam that ties into your original footing. That would be great. Or if you're going to do some sort of hillside stabilization using compaction grouting piers, which that would probably be the most expensive out of absolutely everything. Remember, injection grouting using HDPF will provide a resistance or reduce lateral loading on things, so that helps tie all this together. We've done quite a few projects of these now. It's great, but it's very, very expensive. It's not as invasive as literally everything, but it's very expensive. So for a home like this, I would suggest not doing that. And then either you address the house separately from the hillside with the expectation set that you should expect to see continued movement, and that movement obviously wouldn't be covered under any sort of a warranty. Or if the homeowner doesn't have hundreds of thousands of dollars to pitch at stabilizing their entire hillside, whether or not that's even doable, just ask Palos Verdes, then you address the structure itself and exclude the hillside, and make sort of a value engineering repair for that particular type of thing. So anyway, guys, sorry this went kind of long. I wanted to show you the photos and go through the hillsides. It was a great little case study on evaluating hillsides and some of the issues that come along with it. A lot of it, guys, there's a million things, right? You can be putting a retaining wall down at the bottom and it will help provide resistance. You can do more drainage. You can do over-X and new combat. Like, there's a billion things you can do. I'm just addressing the home foundation repair part of things. So please don't be too critical of the fact that I'm not going into literally all of the engineering nuances that go into this, right? Remember, the best step you can always make when you're doing a foundation leveling and stabilization project, call an engineer. That's been my theme since day one. That will be my theme until I die. Thanks so much for listening. Hopefully you got some information out of this. I was excited to share it. If you guys had any questions, comments, concerns, please drop a line below or message me directly. Please like, share, subscribe, and do all the other fun jazz that people do to share online presence, I guess. Thanks so much, guys. You have a great day.